In this video, we will learn some basic rules in algebra. Let's start with variables and constants. Variable is a letter that stands for number. For example, A, B, C, D, E, X, or Y. And these letters can represent any number. A could be 1, 2, or 3. X could be 5, 7, 11, or 12. Y could be -1, -14, or 100. Constant is a number that does not change. Constants are 1, 2, 5, 7, 11, or -15, or any numbers. Coefficients. Coefficient is the number in front of a variable. For example, 3x. The coefficient of this example is 3. -5y. The coefficient for this example is -5. 1/2 a. The coefficient for this example is 1/2. H. The coefficient for this example is 1. Let me explain more detail on this one. So if you see a variable by itself, for example, x, this actually means 1x. If you see a variable y, this actually means 1y. So that's why when you see a variable by itself, the coefficient for that variable is always 1. Expressions versus equations. Expression, it does not have an equal sign. So expressions are just, for example, 3x plus 5, 5h plus 2, or 6y plus 1, or it could be 9ab plus 10x. These are all expression. It doesn't have an equal sign. Meanwhile, equation, it does have an equal sign. So if you remember, our expression is like 3x plus 5. Equation is 3x plus 5 equals 9. So this equal sign here makes the whole thing an equation. More examples are like 5y plus 9 equals 10, or 9ab plus 9x equals 18. Those are all equation. Just always remember, when you see an equal sign, that means the whole thing is an equation. And when you don't see anything equal, that means it's just an expression. By the way, equation means you can solve it. Not unless it's very complicated problem. Next, like terms. Like terms have the same variable raised to the same power. So the same variable and the same exponents. Exponents and power are the same. For example, 3x and 7x, they have the same variable. They also have the same power raised to power of 1, or exponent. For example, 5a squared and -2a squared. So they have the same variables and they also have the same exponents. Another is 8 and -3. Always remember, when you see constants, they are always like terms. Why they matter? So like terms can be combined. For example, so 3x and 7x, if they are 3x plus 7x, instead of having two terms, you can actually combine them as one. So it will become 10x. That's why in constant 2, so instead of 8 and plus negative, for example, 3, instead of 8 plus 3, we can combine them and it will be equal to 11. More examples. These are some examples for unlike terms. And unlike terms, you cannot combine them. So 3x, for example, 3x and 3y, since they have different variables, even if they have the same exponents, which is 1, you can't combine them because they don't have the same variables. Remember, like terms have the same variable and raised to the same power. Another one, 4x and 4x squared. So they have the same, although they have the same variables, but their exponents are different. This one have 1, this one have 2. So you can't combine them. For example, again, 5a and 7, you can't combine them since this is a constant and this one has a variable next to it. So only combine terms if everything after a number matches exactly or they are both constant. You apply like terms whenever you are simplifying an expressions or equation, and there are terms that match the same variables. Remember, the same variables and exponents. Let's have some more examples. Like 3x plus 5x. That would be 8x. 7y minus 2y equals 5y. 4 plus 9 equals 13. Here's a little bit complicated example, so you can look at it closely. So 6x plus 3 plus 2x. So we have three terms here. And we notice we have one constant, which is the 3. Constant, we don't have any other constant. But we have 2 with the same variables and same exponents, meaning we can combine them. So let's combine 6x and 2x. It will become 8x. And we will just copy 3 since we don't have any other constant in our problem. Another example is 8m minus 3m plus 6. It's almost the same except for we have negative and also we have a variable of m. We can always combine two terms here, which is the 8m and negative 3m when we have 5m, and copy the 6. Another example is 9x plus 2 plus 4x minus 7. Let's try this one together. So we have 9x plus 4x, that would be 13x. Now we have two constants there. We have negative 2 and negative 7. We can combine them since they are both constants. So negative 2 and negative 7 is negative 9. Next is order of operations, or commonly known as PEMDAS. PEMDAS means parentheses, exponents, multiplication and division, and addition and subtraction. All right, let's have some examples for this. 6 plus 2 times 5 equals Okay, let's go back to our PEMDAS, the order of operation. It says we have to start with parentheses, which we don't have in this problem. Exponents, we don't have in this problem. Multiplication and division, we have multiplication. So we have to start with multiplication before adding. So that means this 2 times 5 first, and then add the 6. So 2 times 5 equals 10 plus 6 equals 16. Another example, 2 plus 10 divided by 2. Now, let's go back to our PEMDAS. It says parentheses, we don't have it. Exponents, we don't have it. Multiplication and division, and we have division in this problem, which is 10 divided by 2 equals to 5 plus 2, and we have 7. Here's another example that we have to learn from this. This is very important. When we do multiplication and division, we have to start from left to right. It's same as addition and subtraction. We have to left to right, meaning if you see multiplication and division, which come first, you'll have to do that first before the next one. If the division comes before multiplication, then we have to do division and then multiplication. The same as the addition and subtraction. If the subtraction comes first in the problem, then we have to do subtraction first and then addition. Okay, let's have some example for this one. Let's delete this and let's have some example. All right, 20 divided by 5 times 2. So it says left to right. Now, as you can see in our problem, we have division comes first, which is 20 divided by 5, and then we have the multiplication after, which is times 2. Since we have to follow the rules, which is left to right, now we have to divide first. So that will be 20 divided by 5 is 4. And now we have to multiply the 2. Now the answer is 8. Okay, let's have some practice, more practice. 4 plus 6 times 2. Go back to your order of operations. So we have multiplication first before adding. So we're going to have the 6 times 2 is 12 plus 4 equals to 16. And this one is 10 minus 3 to the power of 2. Now, as you can see here, it says, if we go back to the order of operations, it says we have to do parentheses before exponents. So we have to solve whatever inside the parentheses first, and then we're solving the exponents after. So that will be 10 minus 3 is 7, and then raised to the power of 2. So that would be 7 times 7 equals to 49. Now, how about this one? 18 divided by 3 plus 4. Again, order of operations, we have to divide first. So that would be 6 plus 4. We have 10, and so forth, so on. Okay, that's all for today, everyone. Thank you so much for watching. If you like my video, please press like and subscribe to my channel. Bye.